Okay, let's unpack this. We're doing our deep dive into the State of AI Report 2025. And for an expert audience like you, this report, well, it's more than just news. It's really the essential, curated summary of the year's biggest moves.
Helps cut through the noise.
Exactly. And our mission today is pretty focused. We want to synthesize those key research breakthroughs, look at the incredible commercial scaling happening, and then analyze the geopolitical side of things that this growth is stirring up.
Yeah, we're zeroing in on that intersection of research industry and politics because, even as the big closed models get cheaper and more capable, there's this undercurrent fragility in the core tech in this intense race for infrastructure. That's really shaping the next couple of years.
Let's kick off with the research front. The big theme, really the defining theme this year, was the push for reasoning. You could say OpenAI's O1 preview really ignited that race, introducing inference time scaling in a new way, right? And that scaling came from using reinforcement learning, RL, but crucially, using chain of thought code FA, almost like scratch paper during inference. It let the models tackle much more complex problems, especially in math and science.
Precisely. But the challenge came almost immediately from DeepSeek. The Chinese labs spun out from that quant trading firm. They launched R1 Late Preview and pretty much right away started pushing the frontier models on reasoning benchmarks.
And it wasn't just meeting the standard, was it? The report says R1 Lite Preview actually beat O1 Preview on the AMI 2024 pass at one benchmark, 52.5 versus 44.6. But hang on, DeepSeek apparently did this using verifiable, rule-based rewards, R10. That sounds simpler, almost a step back from complex neural rewards. Are they suggesting simpler RL is actually better here?
That's the really interesting part. DeepSeek's R10 uses these verifiable rewards. They're simple, rule-based, and importantly, much harder to game than a big neural reward model. And they combine this with something called Group Relative Policy Optimization, GRPO. It's critic-free.
Critic-free? How does that work?
Well, it compares sampled answers against each other internally. So you don't need a separate reward model, and you don't need a value head either. The innovation seems to be moving towards these more robust, lower variance RL methods, even if they look simpler on the surface.
Okay, but this brings up a real tension. Because despite these big benchmark wins everyone's talking about, the report flags a fundamental issue, sort of an illusion of progress undermining these reasoning gains.
Yes, this is where we need to be critical. When you apply really rigorous testing, standardized multi-seed evaluations, a lot of these RL approaches, well, they drop significantly. We're talking 6% to 17% lower than the headline results.
Wow, 6 to 17%.
And crucially, sometimes these gains, the reported gains, they actually fall entirely within the normal variance you'd expect from the baseline model anyway. So the progress might not be statistically significant or reliable.
So they're fragile. The report mentions concrete examples of systemic failures when things change just slightly. Tell us about that cat sleep finding. That sounds pretty striking.
It really is. Researchers found that just adding a totally irrelevant fact, like putting interesting fact, cats sleep most of their lives into a math problem, caused error rates in models like DeepSeek R1 and Llama to shoot up, sometimes by 7 times.
7 times. Just from that, yeah.
The model basically gets stuck, wastes a ton of compute overthinking this irrelevant sentence. It shows a real lack of ability to just filter out noise.
And Apple's work, the GSM symbolic stuff, pointed towards something similar, right? Suggesting it's less about true algebraic reasoning and more like clever template matching that just breaks when you disrupt the template.
Exactly. So we're building these incredibly powerful systems, yes, but they seem to have this fundamental brittleness right at the core reasoning level.
Okay, so if the core reasoning is fragile, and it wastes compute on simple distractions, the next logical step must be about making the architecture itself more flexible and efficient, right? What are the new scaling ideas coming up that go beyond just making models bigger?
Yeah, the focus is definitely shifting towards more dynamic, flexible ones of doing inference, letting the model explore a bit. One key idea is parallel reasoning, sometimes called branch and merge inference. Instead of just one path, think of it like the model can spawn multiple lines of reasoning using spawn and join operations.
So it explores different paths to maybe reduce hallucinations or double-check its work.
Exactly. And it works. On the countdown task, which is pretty complex, parallel reasoning boosted accuracy from about 60% baseline up to over 83%. And alongside that, there's a big move away from just static pre-training towards continuous sort of on-the-fly adaptation.
Which brings us to things like test time fine-tuning, TTT.
Yeah.
Adapting the model to the specific query as it comes in.
Right. And the cutting edge there, look at ETH Zurich's SIFT method. It uses active learning to pick just a few very specific examples tailored to the query. It consistently beats standard in-context learning. We're also seeing things like local mixtures of experts, which basically optimizes TTT gains for speed, almost like retrieval latency, by building neighborhood expertise into the model.
That idea of combining specialized experts sounds powerful. But hasn't merging models often hit a wall because the unique knowledge kind of gets averaged out rank collapse?
That's been the traditional problem, yes. When you merge experts, their unique knowledge vectors can overlap and become redundant. You lose the specialization. The breakthrough mentioned is subspace boosting. It uses SVD, singular value decomposition, to deliberately preserve the orthogonal, the unique parts.
SVD, like from linear algebra.
Exactly that. Think of it as a smart filter. It makes sure when you merge the experts, you keep the distinct flavor of each one, not just a bland average. And the results are impressive, over 10% gains in the combined utility.
And these efficiency gains, these architectural tricks, they have huge commercial implications. The report emphasizes that while the top models keep getting better, the cost to access that power is, well, it's dropping fast. The capability per dollar ratio is doubling roughly every 6 months.
Yes, that exponential improvement in efficiency, Google's pace, is around 3.4 months. OpenAI is around 5.8 months. For that doubling, that's what's really fueling this massive infrastructure race. The competition isn't just about peak theoretical power anymore. It's fundamentally about who delivers the best capability for the money.
Which takes us straight into the infrastructure build-out. All that efficiency creates so much demand that suddenly power, actual electricity, is the bottleneck.
Yeah.
Not chips, not capital.
Yeah.
Labs are apparently targeting 5-gigawatt clusters by 2028.
The scale is just mind-boggling. You have the Stargate project, this huge $500 billion initiative aiming for 10 gigawatts of capacity just to secure compute. And look at OpenAI's strategy. They're going vertical. Custom chips with Broadcom, consumer devices through that I/O acquisition, and crucially, data centers.
And the report highlights Oracle stepping in big time, right? A massive $30 billion a year deal with OpenAI for data center services.
Yeah.
Seems like they're filling a gap maybe Microsoft and SoftBank couldn't fully cover.
That appears to be the case. It shows the sheer scale needed. Now, thinking geopolitically, what does all this investment and vertical integration mean for the rest of the world? We're seeing a clear split happening in the open source space, even while U.S. labs keep leading on the closed source frontier.
Okay, so lay that out for us. What's the split? While U.S. labs lead the closed frontier, China is number 2 overall, but is really dominating the open weight world. The adoption numbers seem pretty stark.
They really are. Chinese models are surging in terms of adoption. Qwen, just one example, now makes up over 40% of all the new monthly model variations appearing on Hugging Face. That's huge. It's overtaken Meta's Llama, which dropped to about 15% of new releases.
40% from Quen alone. And it's not just the models themselves, right? It extends to the tools.
Absolutely. Chinese teams are taking the lead in OpenRL frameworks. Things like ByteDance's Hurl, OpenRL-HF, the report cites these as the kind of go-to stacks for OpenRL training now. And they often have quite permissive licenses, which helps global developers pick them up easily.
And all this ecosystem shifting is happening while U.S. policy on chip exports has been, well, unstable. That whole H-20 ban, then reversal.
Yeah, that uncertainty, that zigzagging, it definitely seems to have pushed China to accelerate its move towards domestic chips, indigenous substitution. Regulators there are actively pushing demand away from NVIDIA. Domestic players like Cambricon saw massive revenue jumps like 44x because of this push for homegrown inference chips.
It also suggests controlling the supply is harder than it looks. The report estimates, what, $1 billion worth of chips were smuggled into China during that H-20 ban?
That figure alone shows how intense the demand is at the high end. It's basically inelastic. If you close the legal routes, black markets or gray markets will pop up almost instantly to fill the gap.
So the core tension we've discussed is really clear. On one hand, staggering investment, exponential scaling in infrastructure. But on the other hand, fundamental research showing these reasoning cores are actually quite fragile and inconsistent.
It's a real paradox of power, isn't it? We're building these incredibly capable systems, scaling complexity at an astonishing rate, but maybe faster than we're scaling our understanding or the actual fidelity and robustness of their internal workings.
Which leaves us with a final, pretty critical thought for you, the listener, to consider. It's about this tension between raw capability and, let's call it, integrity or monitorability. We heard how advanced RL techniques boost performance, but often make the model's internal reasoning, its chain of thought, harder to follow or less faithful.
Right. So the question becomes, as these systems get even more complex, even more powerful, will the industry be willing to pay a kind of monitorability tax? Will we accept models that are maybe slightly less capable on some benchmark in exchange for being able to actually see inside, understand their reasoning, and ensure they meet safety standards?
A trade-off between peak performance and essential transparency, something to definitely mull over.